Hello. Last time I was in the middle of trying to make a exporter for 3D animations for Blender. So today I'm going to just continue that process and see how far I can get with that. So I'm going to open up the project that I had started last time, and it's got my script there, but I think I want to reload the most recent one. It doesn't change anything anyway. So last time I was able to successfully get all the keyframes that I want in an animation for a specified range. Like I provide the start frame, the end frame, and this goes through and parses out all of the important keyframes in between those two and will give me a list of numbers. So I need to save that, which I do. I have that here. So then I left off. I was in the middle of trying to get the pose, basically the position and rotation of every bone um, in a particular pose, right? So at a particular keyframe. All right, and it's a recursive function, and all I have it really doing is just printing out the matrix of each bone right now. So my goal today is to try to squeeze out of that matrix all of the stuff I need, the position and the rotation. And I think I need to know the parent's ID as well. Let me open up my project here and double check. I mean, I don't even know if what I started is the path I want to go, but so yeah, so each bone has a rotation, a position, and a index to know who the parent is. So I'm just going to try to get that information. And what else? Oh, you know what also I need is I need to get what's called the inverse bind transform. It's the inverse of the matrix when the animation is at its zero, like at its resting pose. For if it's like a character, it's most often a T pose. So I need to set the animation to that position and get the inverse of each matrix at that location, or the inverse of each bone's matrix at that location, if that makes any sense. So yeah, so what I need to be able to do is programmatically set which keyframe I'm at, because I'm going to make it so that every animation that the frame at zero is its resting pose or whatever you call it. I don't know. I'm not big on terminology, if you haven't noticed. So I need to be able to set the key. I mean what did I just say? Set the keyframe in code. So I don't know how to do that. I think it has something to do with the scene here. So I'm going to look at the scenes and see what the scene there is. Okay, so that's an array, and then I can, so let me save this in a variable in case I need to access it later. So scene is that, and then so let's say scene dot, and let's see what they have. Keying sets, no, that's not what I want. Frame set? Is that like keyframe? Wait, was it frame underscore set? Oh, it worked. Oh, sweet. So if I set it to frame 10, and that's there, and then frame 24, awesome. And then back to zero, cool. So I'm gonna put this guy on hold. I'm gonna make a function. I'm gonna say get inverse bind transform. And what this is going to take, it's just going to take in the root, or just one bone, and I'll probably do it recursively, just like I'm doing this one here. So I'm going to say bone, that's like going to be the root bone, or the first time you call it, and then it's really just this, copying this here. But then before I do that, I need to save it in an array. Okay, so since I'm going to do this recursively, I think I have to provide the array that I'm I can call it list, right? Well, I'll just call it array. I don't know. I know it's not technically an array in Python. Okay, so inside this, I'm providing the array, and then I'm going to get the bone. So I'm going to say mat equals the bone dot matrix. And okay, so let me actually do this here. Let me look at the pose. Uh-oh. Control copy. Okay, there we go. So pose is that, and then if I say pose dot bone 0, no, pose dot bones 0, there we go. Okay, so I'm looking at this bone here, and I wanted to look at the matrix. All right, and then I can, with a matrix, I can transpose it, get to the transposed version of it, I imagine. I can rotate it. Scale, I can do anything. But what I really want is the inverse of it, inverted. Invert or inverted? Okay, so I want this to be inverted, but then is it transposed? I think it should be transposed. Let me see. Matrix dot inverted. Let me just run that. Okay, it doesn't give me any errors. So okay, so I guess let me just print that. Put that on hold for now, and then so let me see, get inverse bind transform. Oh yeah, I got to make the array that I'm providing it. So I'm gonna call this bone or actually animation inverse bind transforms, because that's just a list. I'm gonna pass that in, and I'm also gonna pass in the root bone, which is pose dot bones at 0. And that failed. What? That's not what I wanted. What, stop. That's what I wanted. Wow, okay. Get inverse bind, it's bind. There we go. That ran, and it printed out this matrix here. So, looks to me like, okay, so this is the second bone here, and then this is its Y position. I would expect that, or no, I'm sorry, wait. Oh, I forget it's backwards. So this is its Z position going up. And so I would expect, if it were my engine, that it would be here. So I do, according to this, need to transpose it. So transpose. There we go. So I take the invert of the matrix of the bone and then transpose it. And I think that's it. I don't know. So then I want to say array dot. But a matrix is weird, right? Is it? Can I? Let me try. Let me try to extend. I don't know if that works. No, it's adding a vector every time. So I need to do this then. I need to say, I need to actually iterate through this thing. For I in length mat at, hold on, for the length of mat, there we go. And then for j in length of mat, whoa, wait, no, I don't have to do the length. So that's a vector, that's an element in the vector. Does that work? I don't even know. No, it doesn't seem to work. Matrix indices must be integers, not vector. What? 32. I guess I don't know how matrices work. So let me do this. Let me say mat is equal to that, and then now I can goof around and see what mat can do. So mat, what was I even trying to do? Oh yeah, so I wanted to see if like I can print. Okay, so that's a vector. So then what if I say mat? Okay, so that's fine. I don't get why that's... Oh, okay, you know, so I guess this does have to be length then. And then this would be mat I, j. Oh, still errors. 31, what's wrong with 31? So okay, so I guess, never mind. I guess you can't iterate through a vector. I guess I could just get the range of it. Wait, now I've completely lost track of what I'm doing here. And then so this is j in range of length of mat at I. Does that work? Yes, that does work. And then it prints all the individual numbers. That's all I wanted. So yeah, then I'm going to now, instead of printing it, append that to array. Wait, what am I doing? Mat at I, j. Okay, so after I do all that, if I print what an IBT is, should get a whole strew of nonsense. Oh, so that's one matrix worth. I should get the second. Oh, I get it. Yeah, I'm not calling the function right. I need to also pass in the array as well. And that causes problems. Oh, wait. Oh, geez. I'm calling the wrong function. Okay, that's the problem. Oops. There we go. And that looks like an array of 32 floats. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, cool. So yeah, that is apparently working. So I got the inverse bind transforms, I got the keyframes, and now I need to actually get the what do you call it? The position, the rotation, and all that stuff. And the parent's ID. So, okay, so when I'm parsing a bone, for every bone, I need to get all that stuff. So let me just see. So the parent's ID, I'm just going to assume it's 0 at first, and then you got the position, it's going to be something. The rotation is going to be something. And we're going to get all of that from this matrix here. So how do I do that? That's a good question. So if I transpose the matrix, well, hold on. So let me see. Am I parsing the pose? No, I'm not. So speaking, I probably got to pass in. This is going to be done recursively as well. So I also have to pass in the array. But yeah, let me go ahead and get rid of this for now. It's always doing this. Okay, so why are we missing bone? Line 44. I get what you're complaining about. Missing one required position. Oh wait, yeah, duh, I gotta make the stupid array. Okay, so this will be, you know, I probably should do this after. All right, so then I needed a list of the, I'll call this animation poses. There we go. So that's the second bone. So yeah, this needs to be transposed for sure. So we'll say mat is equal to that dot transposed. But when I think about it, it's going to be different based on whether or not it's a parent or not, like, or if it has like a parent. Like, I guess what I'm trying to say, because yeah, the second bone here has to adopt all of the transformations of the root bone, the parent bone, and that's going to apply for any bone you add to that, so on and so forth. So okay, so you know what I'm going to do? In addition to the bone, I'm going to take in the parent as well. And then, so when I call it initially, I'm going to say that the parent is none. Oh, wait. None? Yeah, so if I say none, I think that's Python speak for nothing. Then this will be none. But then when I call it here, so I'm calling in C, but I'm actually, the parent is going to be the bone itself. So that's going to get passed on through. And then so I can do a check here. I can say if, it's not parent, so parent is not none, do this thing. Actually, I don't know what this thing is yet, but I'll just put this here for a placeholder. And then else, we're going to do this thing. So that's, I think, the right direction to go. Okay, so let's think about this. Let's think about if the parent is none. All right, because that's the easier case, right? You just basically take the, wait, so this should be here, definitely. And so then, okay, so then, yeah, so then if it's transposed, which it is, so then the location should be, which it doesn't mean, which actually, you know, I don't even need to transpose it now, because since I'm taking each part separately, then I can just take it from there. So let me, Is there blocked commenting in? Yeah, okay. So, X. Okay, so this is 0, 3, 1, 3, 2, 3, right? So that's that, and then I want position at 0 to equal, oh no, I can't, I just gotta append it. I don't know if I can do that, but we'll see. Append, so that is mat 0, 3, right? Is that? Yeah, I think so. And then this would be 1, 3, 2, 3. Okay, I'm gonna go with that for now. And then, so now I need to build up the rotation, which will be a quaternion, which is 4D. And I think I remember, wasn't there like a 2 something? No, never mind. Oh yeah, 2 quaternion. Yeah, so I can actually convert this to a quaternion very easily, which is nice. So let me do this here. Let me make a rot for rotation. That'll be bone.matrix.2. I guess I could just put mat.2. That doesn't change mat, does it? I don't think so. I guess I can print to see. Uh-oh. I didn't know it was gonna close out all of Blender. Does that mean I lost all of my saves? I was just trying to exit the program so I don't print a whole bunch of extra stuff. Oh, that's dumb. That's very embarrassing. Yeah, it looks like I lost everything. Oh no. Oh, that's embarrassing. Okay, well, back to the grind, I guess. Oh, damn, I don't remember what I did. Yeah, I did that whole inverse buying transform thing. Dang it. Is there like a refresh? I don't think there is. Okay, so I learned that now when you put exit in your Python code in Blender, it'll exit Blender. That's not cool. Oh well. All right, so let's see. What was it called? Get inverse bind transform. That took in the array to add it to. That took in the root bone, and that was it, right? And then that did this at the end. And then that should also be that. And then I got that by saying that this is the bones dot matrix dot inverted. All right, so then I had to iterate through all of that. So I said for I in the length of wait, yeah, the length of mat, is that, no, range, yeah, I in range, the length of mat, okay, so then for j in the range of the length of mat at I. And then now we want to say array dot append whatever is at the matrix at I and j. All right, so that should do that. Let me test it. So I call this anim inverse bind transform. Oops. And get, yeah, I just spelled it right, inverse bind transform. I want to pass in anim IBT and the poses very first bone there, and that's bones. Okay, of course we get errors because I gotta go here and here. And this is complaining because I said bind instead of bind. Same mistake I made last time. All right. Inverse bind transform. Oh yeah, that is a mistake there. Jeez, inverse bind transform. Get inverse. It's probably a different mistake. Nope. Get inverse. Oh yeah, put inverse here there. There we go. All right, and I don't remember what I was supposed to be looking for, but I didn't give me any errors that time. What was I printing? Oh, that's because I'm still parsing the poses here. Oh yeah, I wanted to do this first. Oops. All right. So yeah, now I can just double check print anim IBT and see if that gives me something that looks legit. Yeah, I don't feel like counting all those and seeing. Oh wait, I also needed to. Oh, I completely forgot about the whole setting of the keyframe. So it looks different now because I need to, when I do this, I need to set the frame, the keyframe, to 0. So to do that, I need to take in the scene as well. So scene, so then that's gonna be, what was it again? BPY, so say scene is equal to BPY dot data dot scenes at scene, and then that can now be was it set frame set, that's what it was. There we go. Okay, so when I do this, I need to say scene dot frame. Oh no, wait. Okay, because this is going to be called recursively. I don't need to set the frame every time. Okay, so I'm just going to make sure that before I call this, I set the frame to 0. So that is here. So I need to get the scene first. Scene equals bpy dot data dot scenes, called just scene. All right, and then so scene dot frame set 0. Okay. So let me just, for fun, put the frame as something different, and then so now if I run this, it sets the frame to 0. That's good. And then when I look at the output, yeah, looks a lot more normal. All right, so that is working now. So now back to this thing. Let me go ahead and put that below here. Okay, so I needed to take in some other things. I needed to take in the parent. Oh, I also needed to take in the array since it's recursive. And then I did a check. So yeah, this is also going to take in the array, the bone, and then the parent is bone. And so I needed to say if parent is not none. Do whatever's here, otherwise, oops, not that one, that one. Otherwise, do what is going here. And then this will take care of all the kids. So, yeah, I don't need that anymore. Probably want to do this first. And I can comment this, but I now need to make a list of, let's call it anim poses. Can't remember what I called it the first time. Speaking of the first time, wait, parent, yeah, parent goes after. Let me go ahead and save what I got here, because if it crashes again, I'm covered. So, all right, almost back to where I was. So I was taking care of this one first. So I wanted to get the matrix, which is the bones, matrix, which needs to be transposed. Oh no, I didn't need to transpose it, because then I needed to then have here. So the parent ID is just 0. Parent, wait, no, I need the position. That's what it was. And then the rotation. And so here the position is going to be the matrix at 0, 3. And then this was just 1, 3, 2, 3. Oh yeah, and then that's right, I could also get the rotation by just taking the matrix and going to quaternion. And instead of testing it here and accidentally crashing the whole program, I'm going to just test it here and say that mat is equal to bpy.data dot I forgot where poses was. Objects. Armature dot pose dot bones at 0 dot matrix. There we go. Okay, so then what I wanted to do is print this. I don't think I needed to type print. Yeah, same thing basically. But then I wanted to do mat.to quaternion. And then, yeah, I don't know why I thought that would change anything. I'm delusional, I guess. Yeah, so okay, so this is the rotation as a quaternion. So then I just really add that to my rotation. Oh wait, I didn't even check. That's okay. Forgot. That's what I want to check. Okay, so I can access the individual elements, and it is W. Okay. All right. Just thinking any code here. And then, so yeah, the parent ID will stay 0. So then now, if it's not a parent, oh wait, I need to also, well, I guess after both of these, I'm going to say that the array dot extend by how do I want to do it? Do I want to do position, and then I'm going to go largest to smallest. So this is 4D, this is 3D, this is just 1D. So I'm going to go append, I'm going to extend the rotation first. and then I'm going to extend the position, and then I'm going to just, since it's only one thing, I don't really extend, I append the parent ID. All right, so that's going to happen after, no matter whichever one of these happen. But then here, so when I get the rotation, so really what I need to do is multiply this matrix, whatever. Okay, so let's say mat is again also the bones matrix, but I need to multiply that by the inverse of the parents matrix. So yeah, so let's say pmat is the parent dot matrix dot inverted. And then could you just multiply with the star? So let me see, mm is equal to mat times mat. No. Not supported between. Is there like a multiplication? No, there's no math things here. Let's check the docs. Multiply matrix, and then you provide another matrix. I didn't see that in there. Is that an option? I don't think these are the same type of matrix. This is a GPU matrix. I need math utils. Utils matrix. Oh, here we go. Multiply. Color can't be multiplied. I don't care about that. Huh. Don't tell me that you did not include the ability to multiply matrices. Let me see here. BPY multiply matrices. With the at symbol? Really? If you're correct, then that would be weird. So mat equals mat at mat. Yeah, it didn't error out. I think that's true. That's weird. I'm gonna call that weird. So anyway, bow dot matrix. Oh, but do I need to invert this though? I don't think I do. But I just use mat here. If I invert this one, do I have to invert this one? I don't think I do. I'm gonna leave it like that for now, and then if it's all jacked up, then I'll consider that as a possibility as to why. So I think it's the same thing, right? So wait, no, so pmat. Wait, so basically mat should just be this then. so I don't need to worry about PMAT. Yeah, so then I just copy all this. Actually, all of this. Right? I think so. All right, let me run this, see if I get any errors, which I do. And impose is not defined. Line 78, because it's and imposes. Rotation. Line 55. I don't see where. Oh yeah, all of these. Rotation. Yeah, it's good. Still. Oh yeah, all these too. And this one. There we go, finally. And I don't remember what I was printing. I don't need to print anything really. So, okay. So I think I got all I need. I just need to... Oh wait, no, I'm completely forgetting about the parent ID here. Yeah, so here it's fine, because if it's, there's no parent, then the parent ID should just be 0 anyway. But here I need to figure out how to get the parent's index in this whole tree thing. So... I'm gonna, like I said, I don't care if this code is fast or not. I'm just gonna do it the dumb way. I'm just gonna iterate through for, let's see, I'm not in a loop here, so I could use I, and wait. But if I, yeah, never mind, because if I do that, I'm gonna have to take in the whole pose to know, I need, like, yeah. Well, you know what, just, who cares? This is really just for me. Yeah, so you take the array, you take the root bone. I don't know, it seems really dumb, but so is everything else I write. All right, so for I and J, I and B in enumerate through the poses, pose bones, and then so if the current bone I'm looking at is equal to bone, no, is equal to parent, then I want the parent ID to equal I, right? I think so. All right, so let me print this out here. This is all going to be a disaster. Pose, not... Oh yes, I need to actually provide the pose now, which is called pose. And that needs to get passed on through here. Oops. Okay, so what it should look like is 1, 2, 3, 4 for a rotation. Yeah, so that 3 for a position, and then a parent ID, which is 0. And then again, 4 for a rotation, 3 for a position and a parent ID. Okay, so the amount of data is fine. The actual data itself doesn't look right, because this should be... Well, actually, no. Actually, the parent ID is fine. So I'd have to add a third bone to actually see if that's working. Yeah, so I'm not going to worry about that at all. I don't know. Oh, what's going on? Sometimes it freezes up like that. I don't really get why. Okay, so anyway, so yeah, this only does the pose at a particular keyframe. So I actually need to do this for every keyframe. So let me see if I say now for k in k frames, and those are just integers, or at least they should be. Then I want to scene dot frame set to k, and then parse the pose at each one of those. And then when that's done, I'm going to print out what anim poses are. Oh, jeez. Oh, did I put a colon there? That's weird. There we go. Okay, and then it sets the frame. Okay, I really should print this in a more organized fashion, but that's all I got. So it should be, there's 3 keyframes, and there's 2 bones, so it should be 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2 times 3 is 16 times 3. I can't do that math in my head. 48. Does that look like 48 numbers there? It doesn't. Oh wait, maybe it is. Okay, so let me do this instead. For I and j in enumerate anim poses. I, j. Whoa, that doesn't work. Oh, I put if. Oh, okay, so yeah, this doesn't work either. And I plus j, do it like that. And that doesn't work either. Spend most of my time just printing or just fixing errors. That's all I want to do. Yeah. Okay, so we got 47 things, which counting starts at 0, so 48. Was that what I calculated earlier? I don't remember. So I have 2 bones times 3 keyframes, and each one has 8 things of data, 48. Yeah, okay, so that's, okay, so all I can verify is that the amount of data is correct. Whether the data is actually correct is a completely different story. I can't really test that until I put this code into the engine and deal with it there. So let me go ahead and save that to be safe. And you know, I think all I'm going to do for the rest of the evening is write all of this stuff to a file. and then and wrap it up. So what do I need? So I need the keyframes. So those are useful, but then when I'm actually saving them to a file, I want to always like treat each animation as starting from 0. And then, but I want to log the keyframes. So yeah, so I'm going to definitely need to know. I'm going to keep track up here. So what everything I need to know to run this as a plugin. Well, actually, never mind. I already have that. It says start, the stupid start frame here. So I'm going to have to take that in anyway. So yeah, so it's 1. All right, let me go ahead and just start with the writing the file. Tentacle dot, I'll call my animation data animdat because that sounds cool. And I want to write binary file. And eventually I want to close this file. And so now I need, okay, so I need some, I guess, I don't know if it's considered metadata or not, but I need to know how many bones there are and how many poses there are. So let me actually see, I'm not sure if I, just right here, print the length of pose.bones. Is it as simple as that? I hope so. 2, yes, okay, so that's easy. So we want to first then say array dot, no, it's just, yeah, array dot array, and then I need to put it in as a, it's capital U for unsigned integer, right? I think that's what I used in my other ones. Let me just look. Oh, capital I. Never mind, capital I is what I want. And then the thing I'm actually writing is, as an array, the length of pose.bones. And then that's going to go to file of file. All right, so then I need to do the same thing with the number of poses, which is the same as the number of keyframes there are. So I'm going to put the length of KFMS. And before I write KFMS to the file, after I do everything I need to do with it, I need to actually change what it is. So I need to so yeah, basically just iterate through it, and then for I in enumerate KFMS. Oh no, that's length KFMS. So then KFMS at I is equal to KFMS at I minus the start keyframe, which in this case is just 1. All right, because I want the indexing to start at 0. And I think that's all I need to do. Let me just print. Make sure. Uh-oh. Maybe I can't do it that way. Int object is not iterable. is it talking about? 982. Oh, okay. What the heck? So then if I just print it, then what happens? It's not two files. Is it just file? Oh, is it two? I can't ever remember. I could just look. Nope. Why don't I just look it up? To file nothing. Okay. All lowercase, because it's not the syntax I'm used to. All right. So yeah, there's the keyframes. It definitely looks like a list to me. I mean, I know it's a list because I'm telling it to be a list. So I don't know why I can't iterate through it. That's weird. So if I say, let me try this again. So 4K. In fact, I'm doing it right here. What the heck? Whatever. Okay, so that time it works. So let me try now. KFMS at I is KFMS at I minus 1. And now it bugs out. List indices. Okay, you know, I'm just gonna make a new list then. So I'm gonna say new keyframes. And it doesn't like that either. Oh wait, because this has to be append. Oh, and I got a semicolon too. That was probably why I was complaining. Oh, check the message in the system constant. List indices must be integers or slices. Not. I don't even know what you mean by that. What does that mean? 84. I'm just trying to append to this new list here, whatever you are. Oh, okay, so I guess since I'm doing this, I don't need to enumerate. Okay, how about that, finally? All right, and then this should be new keyframes. Okay, great, perfect. That's all I wanted. So yeah, now I'm going to write that to the file. So array.array. This is going to be well, it's always going to be a whole number, but I'm going to treat it as a float. And then that's going to be new keyframes. Yeah, to file. And then so in addition to the keyframes, I need the inverse bind transforms and the poses, the anim poses. So anim IBT and anim poses. All right. If I run that, it runs and it puts that file on my desktop. So it looks like it's working. All right. Okay, so that's going to be set by the game or the program. That's going to be taken in from the file. That's going to be taken in from the file. Total keyframes is the same as total poses, actually. and then current keyframe. Yeah, I probably need more information than this, but that's a good start. So yeah, I'm gonna go ahead and save everything here and wrap it up for the night, and then next time I'm hopefully gonna be able to import this into the game and, dare I say, maybe even animate some things, but I'm not gonna hold my breath and be that optimistic about it. Just want to make sure everything's saved. All right, I didn't really change anything in here, so I'm not going to... Actually, you know what? There's one thing I did want to do, and I'm going to go ahead and knock that out real quick, because that's going to make things a little bit easier later on. So here in my game, I have this like storage struct. Where is it? Yeah, memory storage. So I got temp memory, then long-term memory, and then like a pointer to like, so I know how much I've taken of this, but I haven't really messed with any of that yet. But I need to. So to do animations, I need to save them somewhere. So I'm going to save them here and then all that stuff. Anyway, but to make it a little bit more straightforward, because over here in my operating system, I have the temp storage buffer here, and then I am initializing it here. Where did I put that? Like right at the very beginning. I'm initializing that here, but then I'm also having the game state initializing its oh no, that's different. That has to be done. Anyway, so what I want to do is take away the ability for the game to allocate its own memory here. I'm going to have the operating system allocate the memory and then pass that pointer to the game state. I don't know why, but it just seems to make more sense in my brain to allow the operating system to do all the memory allocation, and the game state just deals with the memory that it's given. So forgot where I did that. Oh, there it is. Okay. Yeah, because it's also allocating its own memory here as well. So I'm going to do this. Okay, so before I do any of that, I'm going to make a operating system side long-term storage buffer. And then over here where I am doing this, I'm going to basically do the same thing. And then this is going to be a whole gigabyte. And then, so here where I'm telling that the game state's temp storage buffer equals the, oh no, I never actually did do that. So yeah, that's what I'm going to do here. So game state, oh no, it's OS, no, storage, there it is. Temp memory buffer is equal to temp storage buffer, and then same thing for the long-term one. Okay, so if I do that and then I disable those, everything should hopefully still work. Yay, okay. Cool. All right, so that's all I wanted to do. So now I got something to actually save. Git add all, git commit, tag m, changed storage buffer arrangements. Yeah, sure. Okay, that's saving. I'm out of here. Thank you. See you next time.